Thank you all for joining me today. My name is Shafreen Syed, and I'm a Senior Solutions Architect here at AWS. We have a lot of content to go through, so we won't be taking questions, but we have a machine learning Ask an Architect booth where I'll be located just after the presentation, so you can come along and say hi or just ask questions or whatever, so we'll see you there. The agenda for today is going to be an overview of all of the AWS AI services. And we'll walk through some use cases, some reference architectures, and we also have a customer with us, HSBC, who will share their story. And by the way, it's a really cool one, so you want to hang around listening to that. Our mission is to enable customers to transform their businesses by putting machine learning in the hands of every developer. Whether it's a doctor holding multiple PhDs, or it's an application developer with absolutely no prior knowledge of machine learning, or whether it's an enthusiast just like myself who would like to build some cool applications. Our approach for machine learning is similar to the way we've had our approach to the rest of the AWS business. We focus on customers' business needs and developer capabilities and work backwards from there. We innovate rapidly, have a broad and deep set of services, and we focus on providing customers with a choice, which is why we support a lot of these frameworks. We're seeing more and more customers across various industry verticals using machine learning and artificial intelligence. And some of the UK-based customers are within the healthcare sector, for example, the Exeter, or HM Revenue and Customs, or the Formula One Group. We've also got Inner Wisdom, who are our advanced partners and also machine learning customers. And I worked with another customer called Bridgman Images last year, and we've got a blog released, and they're using Translate with the reference architecture and all of that, so go check that one out. So this is a quick summary of our machine learning stack, the right capabilities for the right set of developers. We have categorized the stack into 3 layers. The bottom one is the machine learning framework and infrastructure. These are aimed for machine learning experts, following them to choose their framework of choice, like TensorFlow or Apache MXNet or Gluon, with a variety of GPU and CPU intensive instances. The second layer is the machine learning services layer, which is the platform services where developers can build, train, tune, and deploy machine learning models by using services such as SageMaker or AWS DeepLens or Mechanical Turk. And the topmost layer is the AI services, or the application services. We thought of the most popular patterns for customers for machine learning, and we pre-trained these models. So we have teams working on these models, making them available as an API for customers to consume, and this is as a fully managed service as well. So developers with absolutely no machine learning experience can use these features to build intelligent applications without the need to build deep learning models. And this is the layer that we will be focusing on today. The important question to ask yourself is, what is your use case? What are the right capabilities for your need? Depending on your requirements, you can choose to incorporate one or a combination of these services, which are API-driven, pre-trained machine learning models, and services. You can build these capabilities into your existing applications or new ones to reduce cost, increase speed, improve customer capabilities, and satisfaction and insight, and build intelligent applications. So these AI services used in conjunction can create compelling solutions that really target your business problems and use cases. Let's take a look at each of these in a bit more detail. So first up is our computer vision model, Amazon Rekognition. You can easily add intelligent images and video analysis to your application throughout using simple API endpoints. You can use Rekognition to identify people, scenes, objects, concepts across millions of images to increase searchability, like swimming pools or faces or motorbikes. And face attributes in images and videos are analyzed to determine the characteristics like happiness or age or a beard or glasses. You also have the capability of bounding boxes for each of the faces. So if you're using Rekognition for advertising purposes, you may not want to have text written across a human's face. You can identify a person in a photo or a video using your own private repository as well. And given that you have bounding boxes, for each of these faces, you can easily redact the ones that are not within your repository. It also allows you to measure the likelihood of two faces being identical or the same person. There's a neural network-based models that are used for celebrity recognition as well. These can be to use, of course, identify celebrities or people prominent within their fields. This was actually used at the 2018 royal wedding by Sky News as well. If you want to identify and filter inappropriate or unsafe content, depending on your user needs, you can do that with Rekognition, right? It also allows you to recognize text from images as well, such as street names or captions or product names and license plates. So this is Amazon Rekognition video. You can pretty much do everything that you did with Amazon images, but in addition to that, you can do pathing where you can capture the position of a person in the video. So you want to make sure that this is available to you, but also it makes it completely unique in terms of tracking, because it will track the person whether they're in or out and back out into the frame as well. You can do the usual image analysis capabilities where you detect objects and scenes within videos, and activity detection, which stitches various frames together to identify which activity is taking place. So we've seen some interesting use cases, and Marinus Analytics is one of them. They've used AI to help fight against anti-trafficking, right? Traffickers put out a lot of adverts, print ads, and a lot of images in them. If someone has been reported missing and their image is on file, then Marinus Analytics uses Amazon Rekognition to scan through thousands of these images and match them with the missing person that shows up in these ads, and they can find them. This can be achieved in seconds rather than taking days for individuals to match through each of those. It's quite humbling, actually, to see the impact these tools are making on our society today. Next up is Amazon TextRack. Easily extract text and data from virtually any document. TextRack's pre-trained models eliminate the need to code data extraction, because they've already been trained for you for millions of documents for virtually every industry vertical. So you can lower the document processing cost and only pay for what you're consuming whilst extracting data quickly and accurately. TextRack takes OCR and combines the ability to understand complex text structures, such as tables and form-based data, and enables TextRack to extract this information from a variety of different documents, including financial reports, medical records, and tax forms. So for documents with structured data, you can automatically detect forms within their fields and values, and you can also detect tables within their cells. So it supports synchronous operations, by the way, for near real-time processing of smaller single-page documents, and asynchronously for larger multi-page documents. Let's walk through an architecture. So you have your input and you upload your documents to an Amazon S3, which is a simple storage service. You send them to TextRack and run them through NLP to extract. Someone's enjoying my presentation a lot, I can tell. So send them to TextRack and run them through NLP to extract insights from documents. And it will create a smart index using an Amazon Elasticsearch service, which will allow you to search through millions of financial statements quickly. Now think about this exact same example, but in the form of a mortgage company, where millions of scanned loan applications can be processed in a matter of hours and have that extracted data that can be searched through Elasticsearch. Right? The way the company can do this is they can search for loan applications where the applicant's name is John Smith, or search for contracts where the interest rate is 2%, for example. Next up is Amazon Transcribe. Amazon Transcribe API makes it easy to convert speech to grammatically correct text. No complicated programming is required, just a call with an API with a few lines of code, and Transcribe will return the text from your audio file stored in Amazon S3. You can add new words to the base vocabulary and generate highly accurate transcriptions specific to your use case, such as product names, domain-specific terminology, and names of individuals. Most speech recognition systems today output a string of text without pronunciations. Transcribe uses deep learning to add punctuations and formatting automatically, so the output is more intelligible and it can be used without any further editing. It recognizes when speakers change and attributes the transcribed text appropriately as well. This can significantly reduce the amount of work needed to transcribe audio and multiple speakers, like telephone calls or meetings or television shows, for example. You can also process audio and video files where each speaker is recorded on a different channel, and Transcribe also returns timestamps for each of the words. So then you can easily locate the audio in the original recording by searching for the text. It also provides you transcriptions for a wide range of use cases, such as customer service or subtitling, search and compliance. And let's look at how we can actually integrate Transcribe with the rest of the services that we have. So you have your audio or video input files. You can bunk them into S3, and they can be in common formats like WAV or MP3 or MP4 or FLAC. And as soon as a new file is uploaded, a Lambda function kicks off a transcribe job. It waits for the job to finish, and when it's done, you can then do some post-processing. And this post-processing could be enrichment of your data, right? Where you know some facts that are specific to your business and your use case, and that you want to bring into the picture. So you can put these together using different data sources and use them for future analysis as well. You can actually use Athena to rummage through this data to bring out the results for you, as well as Redshift for long-term data warehousing, for example, or even QuickSight to be able to quickly visualize that information. The next one is Amazon Translate, which delivers fast, high-quality, fluent, and affordable language translation. Translate is a general-purpose neural machine translation that offers support for 25 languages and 595 combinations. It can support real-time applications with a latency of under 500 milliseconds for average sentences and 150 milliseconds for an average short message, like an Alexa utterance, for example. You can translate on the fly. You can use SSL certificates to encrypt your data and IAM controls to access your resources, for example. There's a concept of sentence tag handling that ensures that your source-to-target text styling and formatting is maintained. And this is super useful for translating HTML files. You can also benefit from automatic language detection and translation. And getting started with it is easy. It's available through multiple SDKs. Most implementations just require 3 lines of code. Now think about high-volume, high-velocity data users that is used by your end users, such as tweets or reviews. These may have been too expensive in the past for human or manual translation, but this is where Translate could actually help you gain that insight that is derived from that data. If you're working on a customer NLP model today, chances are that you're happy to have those models in one language, and you're probably not jumping with joy to multiply those models into multiple languages. And that actually presents a business challenge where you're operating in multiple countries and collecting insight from multiple languages, right? So Translate allows you to bring that data and text into the analysis cycle. And this is great for subtitling or understanding your customer pain points. And whether they'd be saying it in Italian or in Spanish, chances are that they'd be mentioning the same features. And we've seen this being used by customers in their production environments where images and user reviews are vital factors in click-through rates on sites such as hotels.com. Okay, next up is Amazon Lex, which provides high-quality language understanding capabilities to natural language chatbots. The key to building a successful conversational interface is an understanding of the Amazon Lex's concepts: intents, utterances, slots, and fulfillment. Intents are what you mean or what you intend when you say something. So for example, if I say, I want to book a hotel, the intention is that I want to book a hotel. Utterance is what you say that has meaning or intent. In the previous example of I want to book a hotel, the utterance that is that which invokes the function. Booking a hotel, in this case, is what we're looking at for an utterance. So there may be many utterances that have the same meaning, And so multiple utterances can lead to a single intent. Slots are like variables or parameters that we need users to provide value for during a conversational exchange in order to fulfill the intent. And slots have data types like time or date or location, etc. So you specify the type when you define a slot. Once we've elicited all of the slot values, we're then ready to fulfill the intent. Fulfillment is what we want to happen as a result of the interaction, and normally we'd perform some sort of task, like updating a database or triggering a workflow. In this case, it's actually booking a hotel. Let's look at an example to look at each of these in a bit more detail. So here the intention is to book a hotel. In terms of the utterance, you don't need to individually give it one question, like I'd like to book a hotel at a time. So you can use a combination like I'd like to book a hotel in London. In which case, you will only need to specify the number of days, so your check-in and your check-out dates. And these will be your slots, right, variables. Lex understands the slots and that it already has, and it will auto-prompt you for the others. So if you say, I'd like to book a hotel in London, it won't ask you which city, but it will just ask you for the check-in and check-out dates. With Lex, you can create contact center chatbots, informational bots, IoT bots, but how cool would it be if you could give your application a voice? Okay. That didn't work. That was meant to, Polly was meant to introduce itself. So you can actually use Amazon Polly, which is a text-to-speech service that uses advanced deep learning technologies to synthesize speech that sounds like a human voice. So Polly supports today supports 58 voices across 28 different languages and has a wide selection of voices and languages to choose from. It streams all kinds of information through to users in near real time. It supports lexicons and SSML tags. This is quite useful when I was trying to get it to pronounce my name right, because I did have to upload a lexicon, and it literally took 30 seconds for me to get it working, and it was incredibly fast and super cool. So pronunciation lexicons enable developers to customize the pronunciation of words. For example, you can specify the pronunciation using phonetic alphabets, product names or names of organizations, in this case, my name. You can change the way it sounds inflections. So if you get it to read a book, it will know how to pronounce exclamation marks. You can also customize control aspects of speech, such as volume and speech rate. We use Polly being utilized, again, in a number of use cases, such as increasing accessibility for people with special needs, mobile and desktop applications, education and e-learning. So one such customer is Duolingo. And when teaching a foreign language, accurate pronunciation matters. If exposed to incorrect pronunciation, learners develop their listening and speaking skills poorly, which compromises their ability to communicate effectively. And Duolingo uses text-to-speech to provide high-quality language education. So next up is Amazon Connect, which is an easy-to-use, cloud-based contact center solution that scales to support businesses of any size. All customers need to do is open up their console, set up their phone number, their call flow, integrate it with Lex Bot, and in an hour or so, you have a contact center up and running in the cloud. Traditionally, this could take weeks, or months even, to get a quote. So it comes with all the standard functionality that you would expect to have in a call center, including skills-based routing, which is a very sophisticated mechanism of routing the call to the right agent based on the information you already know about the caller. You can create real-time performance dashboards, so you have a visual of what's happening in your call center. Call recording is attached to those reports, so you can then go back and listen to the call directly from your reporting. It produces high quality voice capabilities, which delivers over a soft phone to agents that we call contact control panels. No software or plugins to download. Let's look at an example. So imagine you're running a call center for an airline. You get an incoming call which initiates a CRM lookup and a check in your flight booking system. to identify who your caller is. Right? In this case, it's Adam Hunt, and we've derived that information from your CRM database. The lookup from the flight booking system is to identify why must he be calling. The information it gathered from all of those lookups is that the flight was canceled, so the bot will then, the system will actually greet Adam personally saying, "Hi Adam, I see your flight was canceled today, how can I help you?" He can then respond in his natural language, having a natural conversation, saying, "Can you please rebook me for the same flight tomorrow?" And the system can go back to the database, create a booking, and respond to Adam and say, "Okay, you're now booked in for a 9 a.m. Departure tomorrow out of London City, arriving in Glasgow at 11:45 a.m. So this is an example of a contact flow that creates a customer experience that is dynamic, personal, and natural. The AWS platform services offer the ability to connect to a rich experience. For example, you can take all your call recordings and store them in an S3 bucket, or you can let the system generate the bucket for you. You can also connect the agent data to systems like workforce management or scheduling and forecasting, and the metrics are all available within the Connect application, but they can also be streamed to your data warehouse, and you can do this using Amazon Kinesis. The contract control plane, which is our agent soft one that I talked about earlier, can be used out of the box as is, or even connect to other applications such as CRM or your custom applications as well. Contact flows can leverage services such as AWS Lambda that trigger business logic or retrieval of data from your customer databases. So the next one up is Amazon Comprehend, a fully managed and continuously trained service that helps you extract insights from unstructured text. Think of each of these features and capabilities as feature APIs. We use deep learning to power these APIs, which results in high accuracy and continuous improvements over time with usage. So you can extract sentiments from data. This could be positive, negative, or mixed sentiments. Entities extraction, where entities like people, organizations, numbers, dates, or commercial items can be extracted. Key phrases, which give you the important phrases in a text, like beautiful views in a hotel review. But you can customize Comprehend to identify terms that are specific to your business domain as well. You can actually give it text, and it will detect the language as well. And today, it supports over 100 of these. Topic modeling, you say you had, say, for example, 1,000 customer incidents reported. With topic modeling, you can organize those into 10 or 20 different topics that would help you understand what the customers were saying across that broader corpus. So here's a visual example of feature APIs. So on the left is a snippet of information, and on the right-hand side is the output that you'd expect the service to deliver, right? So these are examples of named entities like organization being Amazon.com, location Seattle, people Jeff Bezos, the date being the 5th of July. Key phrases gets all the noun-based phrases like our customers and books and blenders, and so you get extraction from that unstructured text of information, allowing you to understand what the text is actually about. The sentiment here is positive, and the language detected is English. The language API actually comes in really handy when your business or your application deals with multilingual data, and you can have customers across the globe as it helps you understand the language your customers are communicating in. If you were looking at deriving the sentiment out of a tweet or a customer review, for example, then that can be achieved as well. No models to build, no curation of data, simple sentences, and that's it. So moving on to Amazon Comprehend Medical, which is an extension of Amazon Comprehend. It uses advanced machine learning models to accurately and quickly identify medical information, such as medical condition, medication, dosage, strength, frequency from unstructured data, such as patient notes and clinical trial reports and other electronic health records. So next up is Amazon Personalize, and it makes it simple for developers to create individualized recommendations for customers using their application. Personalize can be utilized with almost any product or content to deliver high-quality recommendations in real time. You pay for what you consume. There's no minimum fees or upfront commitments for this. And we've seen customers like PlayStation and Domino's and Zola and Spule and Navitam use these in their environments today. You can have all sorts of data as inputs to personalize. You can provide an activity stream from your application like page views or signups or purchases, along with an inventory of items that you would want to recommend, such as articles or products or videos or music, and even additional demographic information from your use cases, such as age or geographical location, etc. The output will be a customized, personalized, and recommendations API ready for your consumption. We do a lot within that black box. At each stage, the personalized service is leveraging all of the experience of Amazon.com in this domain. We grab features from the files given, select the correct algorithm for training, derive the training hyperparameters, train the model, host the model, et cetera, et cetera. From a non-data scientist perspective, this is actually a black box powered by the know-how of Amazon.com. We're literally giving our customers that huge knowledge base, giving them a massively powerful AI ML solution. The first is the choice of the algorithm. So yes, with AutoML feature, we will find what we think is the best performing algorithm for you. But you may have years of experience with your data, and you may know for a fact that for your particular use case, feed-forward neural networks are the best choice. So by all means, tell us, and we'll use it. Once we've identified the feature that have decided on our algorithm, we'll choose what we believe are the right hyperparameters. Like the algorithm choice, you may have deep insights into your data, and even if you agree with the algorithm of our choice, you may not want to use these training parameters. So override them and specify the ones that make more sense to you and apply to your, and apply that hard-earned data scientist knowledge as well. So you may also be a more advanced user, and you may have written your own algorithms and have total understanding of how to identify features in your data sets and do all sorts of clever transformations on the way. So why don't you just tell us to use that? And this works for you by containerizing your algorithm, making sure it's stored in ECR, ensure that Personalize can access it, and supply information that lets Personalize know how to train and evaluate your model. So this is the last of the services, which is Amazon Forecast, which is a fully managed service that uses machine learning to deliver highly accurate forecasts. So based on the same technology used at Amazon.com, Forecast uses machine learning to combine time series data with traditional variables to build forecasts, right? You can utilize it for high-level business use cases like supply chain forecasting, sales forecasting, web traffic, advertising demand, or even AWS usage that you have on in your environments today. This is as before that we saw for Personalize. The only difference being the output it produces is a customized forecasting API for your consumption instead. Again, with the black box, we do a lot of fun stuff, from choosing the algorithm to training the hyperparameters, the model, and hosting it. And, but you can also totally customize this by overriding the algorithm and hyperparameters and also containerizing it. And the output that, like I said, all it produces is a customized forecasting API, which is ready for your consumption. And now, please join me in welcoming on stage Garrett Butler, Senior Program Manager from HSBC's Global Risk Innovation Team, to walk us through their journey.
Many thanks, Shafreen, for a great overview of AWS's services. And hello to all. My name again, Gareth Butler. I work in the Risk Innovation and Transformation team at HSBC. So I wanted to take some time just to bring to life how we're using some of the products that Shafreen mentioned with respect to a particular project internally. And before I do that, I just wanted to highlight a couple of factors. Most of this will be common knowledge, but so we're a big international organization, 3,900 offices, lots of customers, present in 67 countries, and 235,000 or so staff. So not unlike any other organization of our size, we have many regulated markets to operating in, many complex processes to navigate, and we have staff with a high demand for information. That could be information about how to run a process, how to find out how to access a system, a whole host of different reasons. So employees today, they find that information through either contacting a SME, a subject matter expert, or they'll look at the intranet, or they'll look at internal department documentation to find the answers. And that's fine, but when you add up the number of queries over the course of a given year, it can get into the thousands or tens of thousands in some cases. And some of those queries can be quite repetitive in nature. So, perfectly natural situation for a firm of our size, but we wanted to look at an opportunity as to how we could use innovation to help those asking the questions and also those answering them. And we reached out to AWS ProServe to experiment. So just before I go into the solution itself, then I just wanted to highlight a demo. And effectively, what we've done is we've built a virtual assistant that's able to ingest raw policy documentation and combine that with FAQs to field a range of queries from our internal staff. So hopefully this is going to work.
The HSBC Risk Innovation Assistant leverages artificial intelligence and machine learning techniques to deliver an enriched user experience for policy document knowledge transfer. A policy expert uses this interface to upload a document, which is automatically divided into sections and tagged with deep learning and natural language processing techniques on AWS. The expert is then able to examine the sections and the generated tags, add more or delete some of them. When the expert is satisfied with the result, they can submit the document, which will now be indexed in Elasticsearch for future reference by the assistant. The assistant is now able to analyze questions and match them with tags in Elasticsearch. By leveraging that, it responds to the user with a matching section of the document. To facilitate value delivery in a global setup and to reduce the need to have policy content corpus in local languages, the assistant allows for a multilingual language extension capability. A knowledge base developed in English can be extended to non-English languages using Amazon's Translate service. The Translate service is supported for custom dictionary integration to accommodate HSBC-specific acronyms and keywords. Leveraging that, the assistant automatically detects the source language of the question and provides an answer in that one. Besides the web UI, there are more ways to access the assistant. An example is a mobile application that can be accessed through an Android or an iOS device. The mobile app assistant has access to all the key features that were mentioned previously and provides an easy and fast way to access knowledge extracted from policy documents. Finally, the user is able to vocally interact with the assistant via an Alexa device.
Alexa, launch HSBC Risk Innovation Assistant.
Welcome to HSBC Risk Innovation Assistant. I am your virtual assistant.
Why am I not permitted to join an investment club?
Because investment clubs potentially involve multiple parties making joint investment decisions, and this practice may expose employees, and indirectly HSBC, to undue reputational risk. For example, should investments suffer, or there may be limited ability to demonstrate your involvement when part of an investment club.
So just a short demo there to help to bring it to life, and that was put together using test data but should give a good flavor for some of the interactions that the virtual assistant has. So just to touch on the solution architecture itself, and really that splits into two parts. The first one is policy ingestion, and the second one is responding to queries. So let's look at policy ingestion. So a key feature to highlight here is that we're using machine learning to automate that ingestion process. So that's cutting down the number of hands that need to touch the document to get it into the solution. When the solution or the assistant ingests the document, it works out or it generates the list of intents that hold that document together. And it does that by semantic role labeling and deep learning techniques. And the output is then validated by a subject matter expert or policy expert or whoever is uploading the document into the solution. So the second stage of the ingestion process is the application of tags. So what happens here is the upload goes into S3, it's then sectioned. The tags, again using NLP and deep learning techniques, are applied to the document. That's validated. And then we're using comprehend, which can basically extract the tags and make them available to the Elasticsearch service. And I'll go into that in a bit more detail. And then throughout the course of those interactions, we've got DynamoDB that's keeping a tab and basically logging everything for audit trail purposes. And just to recap on the top, because I skipped over that. So when the document comes in, it's going into S3. Lambda is routing it into EC2, where we're hosting pre-trained models. And then Lex is acting as that control panel. Just reference some of Shafrin's earlier comments. And that is used, Lex is used more in the fulfillment of the queries, which I'll get into in the next slide. Okay, so responding to queries themselves. So we took three approaches when we looked at queries. The first one was based around setting up prescriptive rules. So ask a straight question, get a straight answer back. Nice and easy when the question's simple, but people don't tend to ask simple questions. They tend to ask things a little bit more wide-ranging, or maybe they're not sure of what the virtual assistant can do. So the second set was defining workflows and decision trees. So these essentially go back to the user and prompt them. You know, they prompt for additional information to steer the question and ultimately to get to the correct answer. And the third stage is using deep search. So that was, again, if you think back to comprehend and making available the tags for Elasticsearch. So the user has the ability to query through the deep search capability the policy document, and that will return the relevant subsections and incorporate that into the answer. We've also got language capability through Translate, so you don't have to take every policy document and convert that into local language. You can make use of the system, have a base language in, say, UK or English, and then convert that to 1 to 25 languages, depending on your organization's demands. So throughout the implementation and the testing, numerous challenges were faced and overcome. One was we initially started experimenting with very structured document sets and FAQ sets, and that involved manual tagging. And for an organization of our scale, that wouldn't really be scalable over time, and certainly not as we used more policies into the system. So hence we needed the machine learning to automate that process and to apply the tags, and then to give the SME base the opportunity to validate rather than manually set up and validate. Secondly, workflows. So it became very obvious during testing that not everybody understood what the virtual assistant could do. Some asked questions way outside the realm of its capabilities, and therefore we needed a channel, and that was the workflow that I mentioned and the decision trees that are all stored as snapshots in DynamoDB. So that was used to overcome that. And just general comments. From a governance perspective, it's been very important to have the ability to generate copies of transcripts of user interactions with the system, to play those back to the users or for audit trail purposes. And equally, we've used serverless architecture so that we've got that inbuilt scalability, so we can ramp up. So in terms of next steps, then this opens the door to more policies, more information. It doesn't have to only be policies. Any standing body of data, anything on which there are questions could lend itself to ingestion in a solution like this. As we do that, we need to think about, well, how does that ecosystem fit together? So we have multiple underlying SME bots. You know, how does a multi-channel query that touches many different aspects of those policies or data stores navigate its way through the system? How do we give a good response back to the user? So as that footprint of chatbots grows, the ecosystem is going to become quite important. And from a data insight point of view, as we do that and we have more interactions, more machine learning brought to bear, and hopefully we can use more algos over time from AWS in the solution, then we can derive behavioral insights potentially, or other insights that we wouldn't otherwise be able to see, and feed that back in to the creation or the adaptation of the source document itself. So ultimately we should be able to lower the queries by provision of better information, or at least understand the nature of the queries. So with that, that's me done. Thank you very much for listening.
Thank you so much, Gareth. So that was a really cool story, right? So like I promised at the beginning. So just a quick summary. I just hope that this session has been thought-provoking and you're eager to build some intelligent applications using the power of artificial intelligence and machine learning. And going forward, if you like to see more of these kind of contents, what you want to do next year, like I said, we work backwards from our customers, so it would be absolutely amazing if you can go into your apps, the AWS event app, and give us some session feedback so we know what we can position for next year. And if you haven't downloaded it already, there is a QR code for it, and we look forward to seeing you all next year. Thank you very much.